I think we'll go ahead and get started here, and folks are welcome to catch up as they arrive. My name is John Pritchett. I'm a math teacher in residence here at NumWorks. I'm joined today by my co-host Gerald Simmerling, who is an IB math teacher here in North Carolina as well, and a NumWorks user. Today we have the pleasure of presenting our Exploring Calculus and Data Analysis in the IB courses with NumWorks. Tried to kind of target overlap between the applications and the interpretations, or applications and analysis classes, so that we could meet as many needs as possible. I did want to mention that the calculator I use for display today is going to be in IB exam mode, just so we're aware of how all of those things are going to look and such. So let me get to, there we are, and sharing this. There we go. Okay. So today we're going to be looking at solving some problems with derivatives and integrals, a little regression analysis, and a little bit of distributions. And if you want to follow along, you can do that. If you have a calculator in hand, that's great. If you want to follow on our website, that's www.numworks.com, and just select the Try It Online button right there in the middle. We also have a free app for smartphones, so just check your app store for NumWorks and can download that. It behaves exactly the same as the handheld calculator. If you're working with the calculator, here's just a quick walkthrough of how to get to IB mode if you've never done that before. So from the home screen, and I'm going to demonstrate this here on my demo calculator. From the home screen, go to Settings. A quick jump to Settings is just press the number 0 on the home screen. The first 9 applications are numbered, so you don't, if you're putting them in test mode, you don't have to scroll down and over every single time. You can jump to Settings. And then down to exam mode. Now it's going to say reactivate IB exam mode because I've already put this one in there, but you're going to have some choices there. There's star exam is Texas, North and South Carolina, Pennsylvania, and then the one at the bottom is to activate IB mode. When you activate a test mode, it's going to ask you to confirm. You're going to throw away all your scripts, all your functions, all your data, everything that you put in there to be in this mode. Yes, I'm sure I want to do that. And so the thing to note, if you've never worked with a calculator in IB mode before, is the letters IB and that little graduation cap show up there in the top banner, so you know that the calculator is operating in IB mode. So then we'll go ahead and get started with our first guided example here. Excuse me. So sorry, let's go back to home. So let f of x equal 4x minus 3 to the 0.25x squared for 0 is less than or equal to x is less than or equal to 3. Sketching a graph, and Gerald and I were talking about this before we started. I always talked with my students about there being sort of 3 levels of graphing. There was draw, there was sketch, and there was graph. And we talked about the meaning of the word sketch. Not a whole ton of details, but you can tell what it's going to be. What I would recommend to a student is going into the grapher. I'm going to add this, and I'm going to add this as f of x. I'll explain why in just a little while. So to do that, I go over to templates. F of x is 4x minus 3 to the 0.25 x squared. And then while I'm here, just to get that restricted domain, I can go over to the addition. It looks like the additional results, but the 3 dots here on the side. And I can set my plot restrictions so that my x's are only from 0 to 3, not 1, from 0 to 3. And when I confirm that, now I'll take a look at the graph. And I would suggest to a student, grab the details that you see. Grab the x-intercept that's there. So it's marked as a 0, the function. Make sure to grab that maximum point. And it does, just to show you what else going on here, that it will go out here only to 3 and stop. So it gets to where x is equal to 3 and a very small y value. To find the value when f of x is equal to 0, when f prime of x is equal to 0, I've got a couple of choices. If I've got kind of a global view of what's happening in this domain, this section of the domain, the only place that f prime is going to be equal to 0 is going to be at that maximum point. So I can grab those values, making sure that I put x equals 2.119 or 2.120. I also have the option of going up to the calculate menu. I can do this by pressing OK on the function as well. And I can display the value of the first derivative. So here, now when I go back to the graph, I now have an additional outlet, a line output for the derivative, and it doesn't get quite exactly there until I get to the actual point. So there's where I can find where f prime is equal to 0. My third option is I can use the equation solver. So I can come over here to the equation solver, add an equation, but I'm gonna add an empty one. Under the var key, this is why I created it as f of x. When it's f of x, it's portable. I can take it into the other applications. So I'm going to choose my functions. There's my function. And if anything here is too small to see, let me know, and I've got a larger version of the screen that I can show you. If I do alpha and the toolbox gives me a prime notation of x, shift pi is equal to and 0. Or in the equation solver, if you just put in an expression and not an equation, it defaults to equal 0. And so now I can just come down here and have it solve the equation, and it very quickly gives me my 2.12. The equation solver sometimes can be kind of slow, and if your equations get to be kind of involved, then so it may be better to solve something graphically than it is to solve it here in the equation solver. But there I'm able to track down my 2.12, 3 different methods. I like the multiple representations because I can talk to students about a maximum point about on the graph where f prime is equal to 0, or I can get into the equation. At any point, if you have any questions, please let us know. Be happy to discuss those as we're going along. Yes, in the equation solver, you can make it prime. So let me do this just for a moment and get that full screen. So here in the equation solver, I selected f of x. I'm just going to put this guy in here again. From the variable key, I'm going to choose f. I come back here to just to the right of f, and alpha and the toolbox gives me that prime. And then I can complete my equation. And if you wanted to do double prime, if you want to find inflection points, it works as well. You just do that prime twice. And again, if I don't make it an equation, it will set it equal to 0. Thanks for the question. Okay. So, gonna put this guy back over here and move us along to our polynomial. Gerald, I'll let you handle this one.
Yeah, so for the next question, I actually just got done doing this with my SL seniors. Very common question. It says, find the stationary points of a function. Several ways to do this. My kids always ask, Simran, what is the best way to do it? And I said, well, we've learned multiple ways to do it. So I really tell them to look how many marks it's worth. So if it's only worth a few marks, or if they ask you to sketch the graph, then that's when I go ahead and jump in and say, let's just graph it, because that's obviously the first way. So John's going to go ahead and type that in the grapher app for us, just as is the normal function. And it didn't give us the thing, so we used the auto zoom. Is usually the best. And so, yeah, you'll notice John was still on his restricted thing, so all he has to do is slide up to the auto, hit enter, and there we go. And then all they have to do, again, determine the nature of the stationary points. A sketch of a graph is enough for their method marks with IB. I've been teaching IB for 15 years now, and I've been teaching math applications, HL and SL, for the last 7 or however long it's been along. Then they clearly say the sketch of the graph is enough for method marks. So if this A was just worth 3 marks or even 2 marks, the sketch of the graph where John would just scroll over, highlight our 2 maximums, and then write them down, and then write down our minimum, and labeling them on a graph is enough to determine if they're stationary points. So then it's, again, if they ask you for this one, and I say, guys, I tell my students, hey, what if it's worth 5 marks? well, that's IB's way of saying, hey, we do want you to find the first derivative and set it equal to 0, and then find those x's, and then continue on with the process. I'm like, I always tell them, if it's worth 5 marks, they want 5 marks worth of work shown. A graph is not necessarily 5 marks worth of work. So that's when I would tell them, hey, find the derivative, set it equal to 0, find your x's, and then if they want the points, plug it back into the original function to get your y values. But we're just going with the graphing technique, so we'll go with that way. Again, state the intervals on which the function is increasing, decreasing. Obviously, they're just going to look at this visually, and they're going to write the intervals in either interval notation or in applications, they are allowed to write it in interval or using inequality notation. But I just tell them to do interval. So they're just going to use the graph as a sketch. Sometimes when it gets to B, I tell them to re-sketch it and kind of label increasing or draw arrows. It's going up, it's going down, it's going up, going down, giving them a little more information, even though the graph from A should be sufficient. I always tell them just sketch it again real quick and then identify and write your intervals, because you're just using those based off the stationary points. And then C, it says confirm your answer graphically, so that's why, another hint, I'm guessing if this were a true IB question, A and B probably would have been worth 5 and 3 marks, and C probably would have been worth like 2 marks, where you would sketch the graph and not knowing exactly where this question, I mean, it's an IB question, but not knowing the mark bands kind of hurts it, because I'm assuming A and B are by hand, C confirm graphically, boom, and then you just decide, obviously talk to them about local or global. Is there a point definitely higher or definitely lower than that? I don't know if you can see my screen, but I'm just going to sketch it. A reminder for IB purposes, if it is by hand, after you set your derivative, so if you set your derivative equal to 0, and then you can use the equations app to solve it, your justification, a lot of times they'll use a little chart like this, and this comes straight from the guide, where you do positive, your slope is 0, your slope is negative. So that, I don't know if you can see it, come a little closer. So that is your justification enough for that it is a maximum. And that's just talking about your slopes leading up to that. So that's another justification if it is by hand.
So just as, and if it's justifying with derivatives, one thing we can do here is to show a plot of the derivatives. So I mentioned you could show the value of the first derivative. You can also show a plot. And in that case, when I come back here to the graph, I see these places that the first derivative is positive for everything up to that point, kind of associating the two together. It's negative until you get back to x equals 0. It's positive again until you get to the other point there. Just having that illustration, zooming out a little bit, may be a little helpful.
Yeah, and the same thing. So like, and Aaron, to your question, a traditional sign diagram, it'll be okay. They'll accept it. And then the other thing I was going to mention, when John just showed you that, sometimes I'll have them not plot the original, since C is basically plot the original function. With A, sometimes, or for A, I'll have them plot the derivative and show, oh, it's positive, it's above the x-axis, below negative, and have them label it. So you can do what John just said right there, which is another good part, especially if this is worth multiple marks.
Okay.
Oh, John, I forgot. We didn't show them, if they don't want to scroll, did you show them on the first one? I can't remember. We showed them that they can actually go to the calculate, and then find the maximum and minimums.
Yes. Yeah, we hadn't shown them that. So yeah, if I come here to the calculate menu and go to find, there's all kinds of things that I can find. Maximum, minimum points, zeros. Just kind of as an aside right here at the moment, that is a dynamic tangent line. So as I'm moving along the graph, this is the tangent to the graph. Then I'm seeing that tangent line moving along there. And then come here, there you go. So after the tangent, we also can find a definite integral. So there's kind of thinking of this in the testing situation, because I know a lot of times they need to show the process, but it can be a great verification that my process went well. I got 12.65 and the calculator got 12.65 as well. Great, that's good.
And if John chooses the maximum, the nice thing is they can quickly scroll instead of waiting for it to scroll left and right. When you choose the maximum, you could just scroll left and right and go back and forth right between the two, and you don't have to scroll over the whole thing. Just a little bit faster, but it's really not. It's easy for the students to use either way.
And the visuals nice and manageable.
Mm-hmm.
All right, good. So For our next example here, we've got a particle moving along a straight line. Its displacement from a fixed point after t seconds is given by that sine function, and for 0 is less or equal to 10. Find the value of q where it comes to rest. And so they've got to do a little interpretation. So I look at doing this one graphically as well. Get that guy out of there. And so I can enter 5.2 times the sine of the square root of 4x plus 6. And so since this is talking about a displacement function, I'm looking at a point. It comes to rest where the velocity is equal to 0. And if I misspeak on any of these, please correct me. It's been a minute. I told Gerald I taught IB when it was math methods. When 2001, 2, somewhere right in there. So if I come here and plot the graph, and I'm still under my restricted domain again, so let's go back to automatic, and it shows me what's happening. I'm looking for a place.
John, will you show them how to restrict the domain from here? I know you showed them in the other one. Let's say a kid forgets and they want to restrict it from this spot, because a lot of them will forget in the first screen.
Yep, got it. So since I have this function selected, I can just press OK, and it takes me to this calculate menu, and I have an option to restrict that domain. So here, if I wanted to restrict it from 0 to 10, as they recommended, and confirm. So it changes my view just because it's capturing that minimum point, is capturing the, it's wide enough to capture the x-intercepts. And so when I'm finding the value of q, that's where my derivative is going to be equal to 0, or down here at this minimum point. So after 4.05 seconds, it comes to rest. And then the total distance the particle traveled, and I was given some really good advice about this. Not at the moment. The one thing that we do have in the calculation app, it's a little bit clunky to get to, and we're asking to have that improved. You can find a degree measure while you're in radian mode in the calculation application. But no, going back to the home screen, and I didn't even look. Should this be in, it doesn't say, should this be in radians or degrees? Should be in radians?
SL only does stuff in degrees. So if this was SL, it'd be in degrees. HL, it's degrees or radians. So chances are this is more of an HL question, though. So I'd guess radians.
Okay. So one nice thing about that, assumes the radians. Okay, good. Thank you, Aaron. I appreciate that. So one nice thing about this, having the numbers on the home screen, changing 2 degrees is not terrible. You just hit home, 0 takes you into the settings app, and the change there is fairly quick. So then if I want to find the total distance that the particle traveled after q seconds, so I want to go from, and here's where I'm going to make a little adjustment to what I did before. If I've defined my function as f of x, it's portable, meaning it can be taken to other applications. And I don't have to use the template. If I know how to abbreviate it, I can literally here just put f of x equals. And so I can take that to the equation solver, and I can enter in the absolute value. We find absolute value in the toolbox. So the absolute value of my function, f prime of x. Yeah. No, that's velocity.
No, you're going to want to do the integral from 0 to 10 in the calculations app.
Thank you. So in calculation.
Yeah, the integral. Yeah, there you go.
Yep. Integral from 0.
Wait, I think you're still in the calculation app, right? Yeah.
Good catch. Thank you.
No problem.
So calculation, I want to go and get my integral. That's what I had out of order. The integral from 0 to 10 of the absolute value of f of x And when I evaluate that, it's going to tell me that it traveled a total of 28.208 meters. So, sorry. Wow, a question came to my mind and it went away. I apologize for that. So questions, comments so far? So Elena, I'm glad to see that you joined us. All right. So
the next question is one comes across in math applications a lot in both the SL and the HL. I'm sure it comes across in math analysis as well. Chances are in math analysis and applications, the HL, chances are they're going to ask them to do this by hand. Obviously, you find the indefinite integral, plug in fundamental theorem of calculus, plug in the A, plug in the 0, subtract, set it equal to 4, solve, et cetera, et cetera, et cetera. More, if this isn't the calculator mode or the SL version, they're not going to ask them to do it by hand. So there are a couple ways that I've done this with my students. The first way is definitely the equations app. It's the fastest way, but we'll talk about the caveat in there. So in the equations app, John's going to go to it, and you can type in the indefinite integral, go to your toolbox, down to calculus, grab your indefinite integral. And I actually learned something today as we were talking to one of John's colleagues, Tracy. I used to always have him just do 0 to x, but here you can actually do 0 to a if you want. So John can type in 0 to a, type in the equation.
And as far as defining this as a function or not, a lot of that depends on how often you're going to use it. If I'm going to do 3 or 4 things with it, I might define it as f of x.
And then the other thing is right here, go back, John, for a second, because this is where my students had a thing. Delete the equals 0 because you did it right. All right, so hit the back arrow once on the, all right. So right here, you'll notice the cursor is really small. If John will you make the screen bigger so they can see it? I want to show them the difference here, because this is something my students mess up a lot. So right here, if John hits the equal sign, don't hit it yet. I want you to see it. Shift pi, and then 0, and then go ahead and hit solve. Scroll down. It's going to say bad. It's a syntax error, but it doesn't look like you typed anything wrong. So John, go back to it. What they have to do is delete the equal 0. If you'll notice, that's a really small cursor. You have to hit the right arrow, and you'll notice it gets out of the integral, and then you put the equal 0. So now he's out of the integral. He hits the shift pi for equals 0 or equals 4. Yeah, sorry. And then down, I forgot what problem we're solving, down, and then solve it, and it will give you the answer A equals. Now, the only problem with this, and my students have found it a lot, it's back to what John mentioned earlier, the computing power of the handhelds. They're going to be taking IB exams. They're going to be using the handhelds and not the emulator does it quickly. Every time I do it, I'm like, what are you guys waiting so long? It takes a while to compute this one. When that happens, because I've seen some of them, it'll spin for 3 minutes on this problem. I'm like, that's wasting too much time. Everybody go back. So what I tell them to do, the faster way is going to be going to the to the Grapher app. So John, if you want to go to the Grapher, and then I'm gonna graph just the integral. Yes, Aaron, we can.
This has to be 0 to x, though, right?
This has to be x, yeah. So the one caveat is you can use A in the other one. This one has to be x when you're graphing it. And yeah, Aaron, we'll jump back to the equations app in just a second. I graph that one. I tell them to graph y equals 4 separately. And then we go to just plot the graph. This is going to be way faster. It sometimes even spins on this to find the intersection, but it's way faster. They scroll to the intersection, get the exact same answer, and then you're good to go. So either way, it works really well. Again, if it's HL and it's not calculator active, obviously we know how to do that. John, Aaron asked if we could go back to the equations. She got false. Let's see what she typed in versus what we typed in. And then Aaron, after the integral, did you hit the right arrow once to get the big line to get outside of it? I did.
You should have a long cursor like this.
Are you on a handheld, Aaron? Or are you on the emulator? Oh, okay.
Oh,
That's
okay.
there it is. Yes, it will tell you false. That's funny. I do that a lot too, and I'm like, well, if it tells you false, you're in the wrong app because you're writing the equation. Yeah, good. Okay, good. Any other questions on that one? All right.
All right. So let's see. Look at this guy. Back over there. And so now we'll take a look at a little bit of regression analysis. I had put this one in here because I'd gotten some questions about X on Y regression, but I'm understanding that's probably old material.
I'm thinking so. Aaron, you can correct me if I'm wrong. I know in applications, SL and HL, they do not do any, they only do normal find the regression y equals mx plus b, where the x goes to the y and things like that. They don't do it backwards. Aaron, have you come across that in math analysis? I don't teach that one, so I'm not really sure. Yeah, okay. So if you want to just show them the normal one, John, where they just regression app, just so they're clear, understand it.
Yeah. So come in here to the regression app, and I'm going to enter my data here real quick. I'm not going to try to talk and do this at the same time, but I will mention that you can, this emulator that I'm using, you can save a simulator session, and data is one of the places where that usually occurs to me, that there's a lot of time and a lot of mistakes that come with students entering data. And so if I wanted this for a homework assignment, I can put the data set in there ahead of time, and then students just work from that saved emulator. It kind of allows you to almost start the problem like 10 minutes in instead of having to go from the very beginning.
Yeah, and I've also used it. I told my kids to create a login for my IAs, my internal assessments. I have them, because a lot of mine do statistics for it. I have them to go in and save it so they can use the screenshots and show me and save, because they use it a lot for their IAs.
Okay. So we take a look at the, oh, sorry, that's not asking any questions, is it?
No, we'll just pretend it asks for the regression.
Yeah. So, so anytime I'm in here in my scatter plot and I've got my my data selected, OK will take you to the regression menu, and we have lots and lots of options here for our regression. It did ask specifically, even though you guys can't see it, that it asked for the linear regression. And what's handy is, well, actually, in the question it was printed, what's the mean temperature and what's the mean number of drinks sold, and that's the landing point when you get the regression, is the mean point. So it handles things very nicely. The other part of the question asked, now right now I'm on the data. So if I'm going left and right, I'm going among data points. I use the up and down to navigate between the data points and the regression model. I would always train my students that if I'm asking about a predicted value, that Y better have a hat on it, and I better see a model. This better read like a sentence. When X is 15, we predict Y is 393 because Y hat, we predict that Y hat is 393 because Y hat is equal to 192, et cetera, et cetera, et cetera. So then if I want to know what's happening when X is 10, I can just type in 10 and it'll jump to it. And it'll tell me that when X is 10, according to my model, get our large screen there. When X is 10, according to the model, we predict that we'll sell 326 or 326 or 27.
Yeah. And John, if you'll scroll actually all the way up under regression, so he hit the OK and got to it too. But if you go all the way up to regression, because a lot of times they want you to write the actual equation and everything out, that gives you everything. So you can write your question. You can ask for your Pearson's product normal correlation coefficient. If you're doing different types of regression, there's your coefficient of determination and things like that. You can actually do residual plots too, which is kind of nice. So there are lots of other functions you can do. Predict Y given the X, which IB says not to do, so I don't ever use that one. No, that's the one I do use. Predict Y given the X.
Given X, what I use. Predict X given Y is
find the X given the predict Y. That's the one. Yeah. The IB application says never to do. They might ask the kids to do it and then say, is this valid or not? And their answer is no, because we should never predict an input given an output. I know that's true in applications because they don't want that. But so they might ask me to do it and then say it's not valid.
Right, because they're, I remember that there may be something about graphing the inverse or graphing the other way around. It's not really going to be the inverse, necessarily going to be the inverse function.
Yeah.
Okay. We took that, so we are up to random sample for.
We're skipping that one.
Yeah, we're skipping that one because that was X and Y.
Yep. All right, so if you've never used any of the distribution, I know in math analysis there's not a ton of distribution, but there is some. I know in applications we do it a ton and we do a lot of it. So the nice thing is all you ever have to do, I always tell my kids, even though I didn't say it in here, the very first thing you're gonna want to do is, okay, normal and binomial. Okay, great. So we're doing a normal one. This is perfect. So with I always tell them write out the distribution. So make sure you write it in the terms IB wants it. So it's always like, for this one, it says chemistry is normally distributed. So I'm like, all right, so we're going to do capital C, tilde, and then I'm like, remember, it's our mean and our variance are what they write in. Now, the calculator asks for difference. So when we're going to the calculator, we're going to go into distribution. Just go to normal. The mean is 60. And again, the calculator asks for the standard deviation. But again, remember your kids that when they give it symbolically, that comma, it's the two parameters are mean and variance when you write it out for IB. They do not want you to write mean, comma, standard deviation. So just make sure that's something you talk about with your kids. I'm sure you do. So our standard deviation is 12. And then this makes everything so much easier with this calculator than it used to be. Good. He's going to hit OK. And now you can type into any three of these windows. So obviously, if we're choosing more than, John's going to scroll to the left, get our drop down, choose more than, and then he got to 80. So we're going to fill in the last mark 80. And there we go. There's the answer. And I tell the kids, make sure you're writing basically what you see. That top little window is what you should be graphing. The probability of X equaling greater than or equal to 80 equals, I basically tell them to write that top thing. And if they want to add the sketch, they can. A lot of times they don't need the sketch on these, but unless it asks for it. So that one's good enough. These same way, except for he switched it to physics. So John's just going to go back, switch our mean and standard deviation to 63 and 10. And then again, he's going to scroll to the left, change it to less than. It actually defaults to less than. It's our first one. We want less than.
Good.
And then less than the 80 he got on physics as well. And it gives you your probabilities. And then they're going to ask you a bunch of follow-up questions. John, you can go to the next slide. The follow-up questions are obviously which one did he, according to others, which one he did better than. So they're just looking at those probabilities. All right, he did better than 95%. Another one he did less than 4.78%. So obviously he did better in physics because only 4.5% did better. That's just interpreting what we've already done, which we all knew to do. The nice thing about this calculator is really for F as well. So we're still in physics, so we still have a mean and standard deviation. Like I said, you can change all of them. So John can actually, he wants to know, find the minimum possible. So for this one, I always do have them sketch, and again, I'll kind of write on the board here. I'm sketch. Okay, I have my normal distribution. I want to make sure that it's the top 10%. So I just have to do that little sketch to kind of remind them, and I'll scroll in if you see my screen. Kind of that little sketch reminding them, okay, we want the top 10%. So then John is going to change it to greater than or equal to, and then he's going to change it to 10%, and it gives us our X value. And you can use the equations app for this as well, for stuff like this. It does work. This is just the built-ins and a lot faster. I will make one side note, since Aaron, you said you guys do binomial as well. I think actually the next one might cover it, John. I think you're using the equations app for the next one. Yes, you are. So we're good. I'll let him take over on that because he's going to use the equations app for this one.
Okay. Just one of the things in thinking about teaching binomial is something that NumWorks does that I think is really clever. Because I would have been this kid. I would have said, out of 20 trials, if my chance of success was 32%, then what's the chance of getting less than or equal to 5.7 successes, just because I was that kind of student? And NumWorks actually corrects you. If you want less than or equal to 5.7, well, you haven't gotten all the way to 6. And so the only thing that makes sense is that it's talking about less than or equal to 5. And this one, as far as where to choose from, we have less than, greater than, between, or equal to. Because we know in normal equal to doesn't make much sense. But here, if I want to know what's the chance of getting exactly 12 successes, then that little tiny bar right there turned gold, take my word for it. All right, good. So back to our normal here for just a second. And Gerald and I were talking about this beforehand. For distributions, I have a mean that is, let's go back here, normal distribution. The mean is 45. The variance is something I don't know, so I can take that out, leave it blank. When I go to my graph, I need to take the fact that they've given me. So x is greater than or equal to 45.37. So I've come here to 45.37. And I kind of think about this as being the score box where this is the proportion box. And it told me that with that score, the proportion that's greater is 0.1714. And what it will do then is to give me the standard deviation down here at the bottom.
John, I'm glad you mentioned that, because I actually forgot in the new upgrade you could leave it blank, because in the first version of it you couldn't, so I was always using the equations app, and I just had my kids use the equations app. So thank you, because now I just remember and learned something.
That's awesome. That's fantastic. But so here you've got kind of three things: the mean, the standard deviation, and the probability. If one of those is missing, and the proportion. If one of those is missing, the calculator can find the missing element. It's really handy to be able to do that. So now when I go back, I can adjust. My standard deviation is 0.39. So now I can come in here and enter it as 0.39. Then I can answer the remaining questions. So what proportion of the scores are between 44.63 and 45.37? And so there's no having to look it up in a table and do this. I mean, I'm going back to when I had to do this in statistics and look up the two numbers in the table. Remember that this one is all the way that way and this is only this much that way. So you got to subtract them and do it.
Aaron, not with, I don't know for analysis. Actually, I'm going to guess no, because I know they don't do any more statistics than application does. And the answer is no. They don't care about that stuff by hand anymore. John, can you go back to leaving the standard? I want to check one thing that since you talked about something. I'll go back and leave the standard deviation a blank.
Okay.
And then hit OK. Go to your far left to the drop down. Can you put in between? Okay, good. So I found a problem. All right, so let's say they give us an in between and ask us for the top end of the in between. So I'm just going to change this problem. I'm just going to make up a problem. So let's say I want the probability. We'll leave the same mean. Actually, we can use that mean and standard deviation. So I'm going to help you guys with another problem. So the probability between, so what was the standard deviation for this one when you found it?
It was 0.39.
Okay. So let's leave those the same. So go ahead and enter those. And then go probability. So leave those. Go ahead. Go in between. And let's say I want to know, I know the probability in between, like, let's say 40 and 44.2 and something is 30%. So, because I actually did this problem with my students today or yesterday. So delete the 44.2. It'll let you know. And put in the 30%.
Oh, stop.
Yeah, it's
yes, I know. Fine. But this is what I want you to do.
Yeah,
so
Aaron, we'll go right back.
The boundaries of the middle 30%?
It will only find the boundaries of the middle. I know in IB sometimes they ask you for the not, so I'm going to show you the equations that, but let's answer Aaron's question real quick. Yes, you can copy and paste, Aaron. So I think you can. Can you scroll down to it on that one when it found the standard deviation?
Yeah, let's get that guy. 44, 45, 37. I know it doesn't have to be the right number.
Yeah.
0.1714. Yeah.
Oh, it's greater than. Yeah.
Yep. Well, I'm I'm into 44s today, apparently.
Yeah. Can you scroll down to it and copy it? I don't know. I've never tried.
Not to here. I can copy the 0.1714. I can copy the 4537, but not the 0.39.
So, Aaron, if you're going to do that, I would say use the equations app, which we'll show right now, and then that way you can copy once you get it from the equations app. So we can actually do the same thing from the equations app. So you're going to type in, so this, you go to toolbox, go down to probability, distributions, and let's just do the one we were doing there. So let's do the normal, and you just got to pick the right one. So greater than should be the first one, right? You can't see it small on my screen.
I think that's defaults to less than.
It does. Oh, good. So when it defaults to less than, you basically got to convince them to do the opposite. So when we choose that one, we're still going to do, yeah, it defaults to less than. So if we're doing it this way, you go there, and then you're still typing the 45.37. And then our mean, which was 45. Next one is our standard deviation X. We don't know it. This is the solving. And then equals. And then I just tell them it's the opposite. So we're doing 1 minus that, John, because we're doing the less than. So 1 minus the 0.17.
And see, my brain wanted to just go ahead and calculate it as 82.
Yeah. Which is why the distribution app is faster for this. So then you hit solve it, it'll solve it. And then, yes, you can scroll over and 100% copy and paste that from there.
Yep.
Yeah, so where I would really use the equations app, if you go back to it, is that when it's not across the mean. So like equations app, delete that one real quick. And you go normal. So toolbox, yep. Probability, distributions, normal. I really use this for the next one, the in-between, when it's not about the mean, because I will run into that problem, not a lot, but a decent amount in IB applications, where it says I want from 15 to something, but it's not evenly distributed about the mean. The regression app, the distribution app gives you when it's symmetric about the mean. This will give you any of them.
And then the mean was 45. And the standard deviation I had copied. So
yeah,
I can just paste it.
And then let's say you wanted the probability to be whatever. And then oh no, you would leave like the 45 empty. So like not that 45, one back. So say you wanted the top end. So we didn't know the top end, X. And let's say the probability was 30%. I'm making up numbers at this point. And then you hit solve, and we didn't screw it up too bad. And there you go. So you would find the top end. Any questions on those? I know we kind of ad-libbed a little bit on that.
All right.
All right.
So any questions, any discussion that you care to offer? All right. Well, thank you all for being here today. I greatly appreciate it. This was my first webinar with NumWorks, so this was a great experience for me. Thank you so much. If you've got any questions about NumWorks or about the IB students, you can email us at contact@numworks.com. If I don't know the IB answer, I'll ask Gerald.
And if I don't know it, I'll ask IB. No, I'm just kidding.
There we go. Yeah, and I'm happy to stick around and answer any questions that you folks have, or just let us know if there's anything that comes up you'd like to talk about. No problem at all. Oh, this is wonderful. That's great.
Yeah.
Thank you.
Your scores will go up. Kids love these calculators. I promise you. I've been using them for 5 years, and they love them.
I had a stats teacher tell me about a month ago that she had actually saved a month of instruction. That she was able to complete her course for almost 4 weeks early, just without having to do so much reteaching and teaching and reteaching of the tech operations and things.
Yeah, absolutely. All right. Well, thanks, everybody. You guys have a great day.
Thanks very much, guys. Outstanding.
Yes, do it. Do it.
Terrific. Thanks, Aaron. Appreciate it.